Show that the line 3x plus 4y plus 20 equals to 0 touches the circle x squared plus y squared equals to 16. Also, we'll need to find out the point of contact. Let us begin. So here we'll start with the equation of the circle. So here we are given the circle x squared plus y squared equals to 16. If we rewrite the equation in its standard form, then we have x minus 0 whole squared plus y minus 0 whole squared equals to 4 squared. This means that the coordinate of the center of the circle is going to be at the origin 0, 0, and the radius of the circle r is going to be 4 units. Now, in order to show that the line touches the circle, so let's sketch the circle and the line. So here we have the line whose equation is 3x plus 4y plus 20 equals to 0. Let's say this is touching the circle at point A. Our goal will be to show that the line is indeed a tangent to the circle. Now what we'll do, we'll try to find out the perpendicular distance of the point C from the straight line, and we're going to use the formula. So let's quickly recap the formula that we'll be using here. Suppose we have a point with the coordinate x1, y1, and then we have a straight line with the equation ax plus by plus c equals to 0. Then if we drop a perpendicular from the point on the straight line, then this perpendicular distance will be defined as ax1 plus by1 plus c whole divided by the square root of a squared plus b squared. Now we'll be using the same formula to find out the perpendicular distance. So let's say we drop a perpendicular from point C on the line. So the perpendicular distance CA is going to be equals to, we'll take the absolute value. Now we will take the ratio in the numerator. We start with the coefficient of x, that's 3. 3 will get multiplied with the coefficient or with the coordinate x coordinate of the center C. So that's 0 times 3 will get 0. Added to the y coefficient, which is 4. 4 will get multiplied with the y coordinate of the center, so that's 0 as well. And then we have the constant term, that's 20, divided by square root of 3 squared plus 4 squared. Now we get square root of 20. Now what's a square root of 3 squared plus 4 squared? So that's nothing but 5. So that means we have 20 over 5, which gives us the value positive 4. And what is CA? CA, if the line were to touch the circle, that means if it were the tangent to the circle at point A, then CA would be the radius of the circle. So we are getting exactly the same result. So here we can say that the CA value is exactly equals to the radius, which tells us that the line 3x plus 4y plus 20 is indeed going to be a tangent to the circle. Now the next goal will be to find out the coordinate of point A. So how shall we proceed? So let us suppose that the point A has the coordinates x1, y1. Now if it has the points coordinates of the point A are x1, y1, and it lies on the circle as well as the straight line, then it would mean that it should satisfy the equation of both the circle as well as the straight line. So our equation of the straight line will become 3x1 plus 4y1 plus 20 equals to 0. So here we will try to isolate y1. So we have 4 times y1 equals to negative 3x1 minus 20. Let's divide each term with 4. We get y1 equals to negative 3 over 4 times x1 minus 20 divided by 4. That's going to be 5. Because the point A lies on the circle as well, the equation of the circle will become x1 squared plus y1 squared equals to 16. We'll replace the value of y1 with negative 3 over 4 times x1 minus 5 whole squared equals to 16. Now when we solve for the value of x1, so x1 is going to give us a value equals to negative 12 over 5. So this I'm leaving as an exercise for you to try, and we can use the equation for y1 to get the value of y1. So y1 will come out to be equals to negative 16 over 5. So now we have the coordinates of the point of contact. So the point of contact will be A with the coordinates negative 12 over 5, negative 16 over 5.